wabarakatuh. Hello guys, welcome back to my YouTube channel. My name is Redindi Sanistia. I'm from group 1. Here, I will explain the material about some properties of liquid and solid. Solid characteristic: definite shape and volume, definite melting point. Amorphous solids do not have a definite melting point. High density. Most substance are most dense in the solid state because particles are so closely packed. High in compressibility, low rate of diffusion, millions of times lower than liquids. Characteristic of liquid. 1. Liquids do not have permanent shape, they take the shape of their containers. 2. Liquids occupy space and mass. 3. We cannot hold liquids in our hands, we can hold them if they are placed in the container. Okay guys, now I will explain the theory one by one. Some properties of liquids and solid. Condensed phases, coefficient of thermal expansion and compressibility, and heats of fusion, vaporization, sublimation. A. Condensed phases. Solid and liquid are referred to collectively as condensed phases. This name emphasizes the high density of the liquid or solid as compared with the low density of gases. This difference in density is one of the most striking differences between gases and solid or liquid. The mass of air in a room would be some 100 pounds. The mass of liquid required to fill the same room would be some 100 of tons. Condensation is a process of change that occurs into a more solid form. For example, is a gas that turns into a liquid. Condensation is divided into two types, namely condensation, exterior and interior condensation. Exterior condensation occurs when moist air touches a cold surface like glass. This condensation will occur if the surface temperature is below the dew point of the air. Interior condensation occurs in a closed room, that is, if the humidity of the air in the enclosed space experiences excess. This excess air humidity sometimes causes condensation on window finish. The more warm air, the more water vapor it has. Okay, the next theory B. Coefficient of thermal expansion and compressibility. The dependence of the volume of a solid or liquid on temperature at constant pressure can be expressed by the equation V equal V0 or 1 plus Kt, where T is the Celsius temperature. V0 is the volume of the solid or liquid at 0 degrees Celsius. And K is the coefficient of thermal expansion. The important difference between the two equations is that the value of K is approximately the same for all gases, while each liquid or solid has its own particular value. Of K in the solid and in the liquid state. The value of K is constant over limited range of temperature. If the data are to be represented with precision over a wide range of temperature, it is necessary to use an equation with higher powers of T. V equal V0 or 1 plus AT plus BT quadrat, where A and B are constant for gases and solid. K is always positive, while for liquid K is usually positive. Okay guys, you can see some of the coefficients that I have written. Linear expansion coefficient, volume expansion coefficient, okay guys, the last theory, C, heat of fusion, vaporization, sublimation. The absorption or release of heat without any accompanying temperature change is characteristic of a change in the state of aggregation of a substance. The quantity of heat absorbed in the transformation of solid to liquid is the heat of fusion. The quantity of heat absorbed in the transformation of liquid to vaporize, the heat of vaporization. The direct transformation of solid to vapor is called sublimation. The quantity of heat absorbed is the heat of sublimation. Sublimation enthalpy formula. Delta H sublimation equal delta H fusion plus delta H evaporation.
No limit in the sky that I won't fly for you. No amount of tears in my eyes that I won't cry for you. Oh no, with every breath that I take, I want you to share that air with me. There's no promise that I won't keep. I climb a mountain that's none too steep. When it comes to you, there's no crime. Let's take both of our souls and intertwine. When it comes to you, don't be blind. Watch me speak from my heart when it comes to you.
The working principle of sublimation, general on an industrial scale, is to separate the sublimator with a sublimator so that it becomes a gas or vapor. The resulting gas is stored, then cooled, condensed again, whereas the simple way of sublimation work on a laboratory scale is a substance to be sublimated put in a cup or cup for outside sublimation. Cover it with a wet glass funnel or pumpkin filled with water as a cooler, then heated with low heat. Solid will sublime, turn into steam, while the mixing agent remains solid. The natural sublimation process, it is a sublimation process that occurs naturally due to the natural process itself. For example, sulfur sublimation that occurs in volcanic craters.